Today we're going to start Chapter 2, and I noticed the first two chapters, or the first three sections of Chapter 2 are minor, and it has to do more with just understanding functional notation. So you have to know what domain, you have to know what range is, you have to know what f of x means, and you have to be able to look at a graph and discuss f of x. You have to be able to look at a table and discuss f of x. And I really feel like you guys are good at this. It's relatively easy, so I want to really knock out sections 1 through 3, and then you will be able to knock out Algebra 2 IXL D1 through 5. Alright, and what I did honestly was I just went and screenshotted all of the IXL problems to make sure that you could understand them. Alright, and basically I looked at the book, and the IXL was a pretty good interpretation of those first three sections. Alright, so I really want you to work hard today. I don't think it's going to be hard at all. I think it's going to be really easy. So let's go ahead and get started. Alright, question number 1, it just says find the domain and range. Alright, for those of you guys who forgot, remember the domain is just the set of x coordinates. The set of x coordinates of the relation. Remember, a relation is just a set of ordered pairs. Alright? And then the range is the what? The set of y coordinates. Set of y coordinates of the relation. Alright? Now, like I said, I think it should be super easy for you. Alright? So what we're going to do is we're going to write domain, colon, and then it's just a list. Alright? Now generally we start with the smallest and largest. So here's how I like to tell kids: if you're looking specifically for the x coordinates, you just find the points and you go down. Alright? So those points are -5, -3, -2. Alright? The range then is the y values. So you would look at the y axis. Alright? And we say the lowest is 3, 4, and 5. So that's how simple the domain and range is. Okay? Now I personally like to put them in ascending order, which means the smallest to the largest. Alright, but it's definitely not necessary. Alright, so here they're just asking for the domain. So domain are just the x coordinates. Alright, 1, 7, 9, 14, 17, and 20. Alright, notice again I just took the time to write them small to large. I noticed in the IXL they don't care what order. Alright, but generally when you're making a list, small to large. Alright, now the range, all we're doing is we're looking for the y values. So I look at each point and I just travel back to the y axis. And then I can just look at the numbers that I have used. So the range is -1, 0, 2, 4, 5. Number 4, again this time we're talking about the domain, so I like to just draw them back to the x-axis. Not necessary, but just helpful. Domain, -5, -4, 1, and 2. Alright? Again, domain for number 5. Looking at the x coordinates, -9, 4, 15, 19. I told you, very easy. Range, again, we're looking for the y values. So here, this one. Now if you notice, these 2 points share the same y value. Alright? So you only have to list them once. So the range, -5, -3, 0. Okay? Number 7, domain, going to the x-axis. Right. So domain, -5, 1, 2, 5. Right. Range, y values. Now again, we don't have to write it. You don't have to write it twice if it's written twice. Okay. Now, we want to talk about, is the relation a function? All right. So now, a relation is a function. All x values have a single y value. All right. Now you've heard me say this before, that something is a function if all of the x coordinates are different. All right. Now we're going to demonstrate that two ways. All right. Graphically. All right. So if you look at this, to check for a function graphically, we say there is a vertical line test. All right. And what that means is if you draw vertical lines, those represent the x coordinates. The graph can only touch it at one spot. All right. If it touches it more at one spot, it's not a function. All right. Now we briefly went over this in Algebra 1, but in Algebra 2 and pre-calculus it's much more important. All right. So here's a vertical line. So if you want to test, you just take this vertical line and pass through the graph. All right. So we say this is not a function. All right. The reason it's not a function is because it touches at 2 points. Now it only has to touch one place, all right, twice to consider it not be a function. All right. So I'm just showing you it doesn't matter. Any of these vertical lines will demonstrate that it is not a function. All right. Not a function. All right. And it does not pass the vertical line test because let's say this x coordinate right here is 2. All right. It could be 2, 2, and then the other answer would be 2, 2, 3, 4, 5, 6. All right. So we say that this 2 is mapped to 2 separate y values. So that's why it's not a function. Okay? Very simple. Look at number 11, or number 10, I'm sorry. So this is using a table, the other is using a graph. So what we do is, the only thing we look at is the x coordinates. 19, 3, 19. All right, so we highlight 19 again. All right, notice that it occurs twice. So as soon as the x coordinate is listed twice, we say it's not a function. Okay, now number 11. All right, what I want to do on number 11, again, because it's a graph, we can just draw a vertical line. All right, notice that vertical line right there crosses at 2 spots, so it's not a function. All right. Down here, all you're doing is looking again at the x coordinates, -19, 9, and 11. Because the x coordinates are different, it's yes, it is a function. All right. Now, I notice I didn't say that the y values all had to be different. For example, 3, 5, 4, 5, 5, 5. That's still a function. It doesn't matter that the y values are all the same. It only matters that the x values are all different. Okay? Now let's look at number 13. Which of these relations is a function? All right, because it's a line, I'm going to demonstrate, or because it's a graph, we're going to draw a vertical line. That's probably a little too thick, so I want to make it a little smaller so you can see better. All right, so there's my vertical line. What I'm going to do is, again, I love Notability because I can make demonstrations. All right, here if I draw this vertical line, it only touches on the first one at one spot. So that is a function. if we go down to the one on the bottom here, that's obviously not a function, right? Because it would touch at this point and this point twice. All right. Now let's come over here. All right. Vertical line. Uh-oh. It looks like a function until we get to this point right here. Notice that this point right here and this point right here. All right. So if I were graphing that, that'd be 1, 4 and 1, 5. Again, that would not pass the vertical line test because that 1, or when x is 1, the y value could be either 4 or 5. All right, so that's definitely not a function, definitely not a function. And now let's grab the vertical line again, and let's talk about this one up here. Function, 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 all the way till we get to this point right here. And notice that this point right here at -4 has 2 y values. Because it has 2 y values, not a function. It only has to happen at one spot in order for it not to be a function. So that is our function. Okay? All the points pass the vertical line test. All right. Is the relation a function? Again, 15, -18, 5, 3. They're all different, so it's a yes. All right. 15 is the relation of function. Again, we draw a vertical line, move the vertical line, and guess what? Passes the vertical line test, so we say, yes, it is a function. All right. Next one is the relation of function. All right. Kind of beating the dead horse here, but I want to make sure you understood me. All right. Does that pass the vertical line test? Yes. It only crosses at one point. All right. Now, we're going to look at a table. Uh-oh, I found one. All right, we found 2 and 2. Then we also noticed that 10 occurred 3 times. So this is definitely not a function. All right, not a function. Okay, let's take a look at what's next. 18 is the relation of function. Grabbing a vertical line, swing it across. Looks to me like a function. Yes, pass the vertical line test. All right. Okay, now these are super important. All right. This is what you'll be studying more when you get to Algebra 2. All right, different types of functions. All right, that aren't lines or a parabola, but have different attributes for different parts or for different parts of the domain. All right, so what we'll do is we'll talk about the vertical line test. So I'm going to draw a vertical line, and then we'll just run it through the first one. Notice right there, 2 points. All right, so that is not the function. Look over here. Uh-oh, look right here. That space right there, all right, touches at 2 spots, so it's not a function. All right, now I'm going to grab the vertical line. That point right there touches twice, so does that point. So again, not the answer. Now we'll come over here one more time. Now, uh-oh, right here. Now that one appears like it has the same point. But keep in mind, that's why that's an open circle. That graph does not have a point at that location, all right? But it goes all the way up to that point. So this is the graph that passed the vertical line test again. Notice here that it almost fails to exist at this point, but because we say that is open, then it's not the same point, all right? So this would be our correct answer here. That's the one that's the function. All right? Now again, another nice little problem here. This is pretty obvious. Does not pass the vertical line test. Now we talked about this enough. That point right there is the same. Does not pass the vertical line test. Over here, that does pass the vertical line test. Does pass the vertical line test. So there you have it. All right. Hopefully I'm making sense here. I just wanted to, this is just basically just like definitions, things you have to understand. All right. And once you understand it, it's super, super easy and helpful. All right. Now we get into functional notation, which it's been a really long time since we've done functional notation. But I just want to remember f of x equals y. All right. So what I want to show you is what's inside the parenthesis is the x coordinate. What it equals to, we say, is the y coordinate. All right. So if somebody writes f of 1 equals 7, that means that the point 1, 7 is on the graph. All right. So again, 1 is the x. What it equals to is the y. All right. Now again, it's been a while. All right. We've talked about this throughout the 2 years that I've worked with you, but not as much as I probably should have. All right. This is called functional notation. All right. And basically what this means is when x equals 3, what is the y value? All right. So f of 3 is equal to 8 plus 6 times 3. That's how simple. All right. You're plugging 3 in for x. So now f of 3, just do our mental math, 26. Now remember, what does that exactly mean? That the point 326 is on the graph. All right. Next problem, all we're doing, f of 2, and I'm just showing you my work because I think it's important. 102, we plug 2 in for x. All right, so we would say f of 2 is equal to 5 minus 51. So f of 2 is equal to negative 46. And it's just a fancy way for saying 2 negative 46 is on the graph. All right. Now we're practicing order of operation. F of 5 is equal to 2 times 5 squared. F of 5 is equal to 2 times 25. So f of 5 equals 50. 5 comma 50 is on the graph. All right. Here we're just reviewing our square roots. F of 36 equals 8 plus the square root of 36. F of 36 is equal to 8 plus 6. F of 36 is equal to 14. All right? Which again, 36 comma 14 is on the graph. Okay? Now, 25. F of negative 2 is equal to the absolute value of negative 2 plus 3. All right? F of negative 2 is equal to absolute value of 1. F of negative 2 equals 1. So again, just for reinforcement, negative 2, 1 is on the graph. All right? Now, this is the kind of stuff that is a little bit more advanced. It seems more advanced, but it's very simple. The question is, what is h of 4x minus 10? So again, that just literally means when x is 4x minus 10, what is the y value? So what does that mean to do? That means to plug in that value. All right. Now in this case, I kind of made a mistake because I didn't realize they were talking about p's. So this should be p is equal to 4x minus 10. So we'll replace p with 4x minus 10. So I'm going to make my note here. Now I'm going to say h of 4x minus 10 is equal to negative 8 parentheses times 4x minus 10. So again, I'm just substituting that in for that p right there. All right. Now we just say h of 4x minus 10 is equal to negative 32x plus 80. All right. 27. All right. H of s of 9 is equal to s plus 9 squared plus 10 times s plus 9 minus 6. All right. Now, who among you looked at that and thought that was s squared plus 81? Of course, no one did, because you've been taught so well. All right, when you square a binomial, you get a trinomial. So this, h of s plus 9, is equal to s squared plus 18s plus 81. Now don't tell me how'd you get that, all right? Because that means you don't know that s plus 9 times s plus 9, s squared plus 9s plus 9s plus 81. So that's your 18s, okay? Plus 10s plus 90 minus 6. Now we combine terms. So s squared 18 plus 10, 28s, 81 plus 90, 171, minus 6 would be plus 1, 6, 5. All right, so again, h of s plus 9. And believe it or not, this is what you're going to be doing a lot in Algebra 2 and pre-calculus. All right, a lot of good information today. All right, let's check out what 28 says. Okay, so now what we're doing is, in the previous examples we had functions, now we had graphs. So you're going to be amazed at how easy this is. So again, g of 4 means to figure out what the y value is when x is 4. So let me show you how really, really super simple this is. All right. So here is 4. So you go up to the graph. When you get to the point on the graph, you see what that y value is. So g of 4 is equal to 6. Look how easy that is. All right. It's asking you to find the y value when the x is 4. All right. So over here, f of 6. All right. So I'm going to go to 6. I'm going to go up to the graph. And once I get to the graph, I'm going to swing over to the y value and see that that's 4. Okay? So again, that's just reinforcing that the 0.64 is on the graph. This is the x, that's the y. Again, I cannot emphasize to you enough, functional notation is in every advanced math course. You have to understand it. It looks complicated, but it's simple. All right? Now over here, I want to really think about number 30 now, because now I'm going to rewrite this as f of x equals 4. So what does that mean? That means x is what when y equals 4. So now I just do it the opposite way. I look at the 4 for the y value, I go over to the point on the graph, I find the point on the graph, and then I go down and tell me what's the x coordinate. So in this case, x equals 4. Or it's kind of a coincidence. I don't really like that problem because it shouldn't be the same. All right, but let's look at 31. All right, so now it's saying y equals 0. What is the x? All right, so I go to y equals 0. All right, and now the y value is 0. So I have to go to the graph, and now the x equals -4. Now how do I know I'm right? Because this point right here is the point -4 is 0. The question is saying, what's the x value when the y value is 0? All right. So again, please don't get confused. If you are, just please go back, listen to the video again, and maybe my explanation will be more clear if you hear it a second time. All right. So again, f of x equals 6. So I'm going to 6, the y equals 6. What I'm going to do is I'm going to slide over, and there it is. So what x corresponds to that y? All right, so it looks to me like that's -9. So x equals -9 when y equals 6. All right. Looking at 33, g of -2. So the question is x equals what when y equals -2? So now I'm going to y equals -2. Uh-oh. This is a great problem because it occurs at 2x values this time. Okay, so what I'm going to do is I'm going to look up here at that x value and that x value. So when x equals 5 and x equals 9, the y value is -2. Alright, so again, you can have multiple answers for this. Alright, you just can't have multiple y values for the same x, but you can have multiple x values for the same y. Alright, you might listen to that again too. Alright, over here, it's just g of 5. So I go to the x coordinate. When the x coordinate is 5, it's right here. Uh-oh. Now this is another nice problem because I'm not sure if it's that one or it's that one. Alright, now remember, it's always the solid dot. So that's the solid dot. So we would say that g of 5 is equal to 6. Alright, this is open, so that means it's everything up to that point, but not including that point. Alright, you'll learn a lot more about that in your Algebra 2 class, okay? So your correct answer is 6. Alright, now let's see if we can find f of 9. So again, I think it's the same type of problem. I'm zooming in on 9, so here's x equals 9. I'm going up. I have two choices, either that one or that one, but we know it's this one because it's the solid line. Okay, so y equals 2 when x equals 9. Alright, 36. What's f of -8? So again, I just take the y value is -8. I just kind of draw a line this way until I find the point of intersection. There's the intersection. So this value right here corresponds to that. So when y equals -8, x equals 4. Alright, so the answer is x equals 4. Really, really good problem. Okay? Look here, f of -3. So it's saying what x value has a y value of -3. So I go to y equals -3. Uh-oh, this one's a really nice problem because there are how many solutions? 1, 2, there are 3 solutions. So when x is -6, the y value is -3. When x is -3, the y value is -3. And when x equals 8, the y value is -3. Alright, so please double check yourself on that and make sure you're good. Alright, remember f of x equals -3, that means when y equals -3, what's the x? Okay? So now they're just making sure that you understand how you find the points on the graph. Alright, so if x equals 4, this is the point, there would be a 6 there. When x is 5, that's also 6. And when x is 7, there would be a 2. Alright, now just to make sure I'm not going too fast, I'm locating these points right here. Okay, so these are the x values here. You want the corresponding y value. Okay, so let's look here. So when is x -2? Alright, so this would be the solution. When x is -2, the y value is -1. When x is 0, the y value is 2. And when x is 2, the y value is 1. Alright? Let's check out 40. Alright, let's complete this table. So when x is 1, 10. 4, 4, 6, 5. Alright, again, just looking. Here, here, here. Alright. -7. Alright, the x value is -7 is there. And the x value is -2. When the x value is 10. Alright. So when the x value is -7, the y value is 1. X is -2, y is 1. When x is 10, y is 3. Okay. Over here, -7 Alright, this one's the nice one. Alright, so you have a choice, is it this one or this one? Obviously, remember, it's the one that's filled in. So that would be negative, made a mistake on that one. F of negative 7 would be the y value, which would be, the y value would be 0. 6 would be 3. 10 would be 4. Okay? Wow, and that's it. Alright, so I'm really super excited about this. Alright, this is going to give you a really good understanding of what functional notation means, domain, range, alright, all kinds of things, alright, that I want you to know before you get to Algebra 2. We discuss it only a little tiny bit, alright, but hopefully you feel a little better now. Alright, again, I appreciate your work. Please work diligently on the IXL. Try to get it done as soon as you can. I was pretty happy with the results of Chapter 1. I'm going to get through Chapter 2, probably slope, writing the equations of lines, graphing lines. On the next lesson, I'm meeting every day. There's going to be assignment. I'm not taking a break because it's too important. I hope you feel the same way. I don't care about this epidemic or pandemic. I care about you guys learning. I really miss you guys, and I wish we could do it a different way, but we're tackling what's been put in front of us, and I want you guys to be amazing math students. So please, communication is the key. If you don't understand something, please talk to me. I've been doing private Zooms with kids if they need it, and I'm available for you. All right, so please, I wish everybody the best. I hope everybody stays healthy, and God bless. I'll talk to you soon. Bye-bye.